Thank you and good morning. Appreciate everyone waking up early to talk about flying robots, or at least that's the way to try and get people excited for it. But no, thank you for taking the time to chat today. Today I am talking about best practices in drone surveying for the next hour and a half. Just briefly, for those of you that haven't met me or don't know too much about me, I'm with Aerotas, and we have been doing drone data processing for land surveyors since about 2014. The way that our company works is we work with surveyors all over the country that send us data and we process it. And that means that over the past 7-8 years or something, we've actually learned an enormous amount about drone surveying, obviously, and what makes a successful drone program, what makes one that doesn't particularly work. And so what I'm talking about today is really a distillation of all of those best practices of the things that we have found make a successful drone program. And I should add a little bit of a caveat to that first, that if you don't do it exactly the way that I am talking about today, that doesn't mean that you're an idiot or doing it wrong or that it can't be perfectly successful. There are actually lots of different ways that you can do it. This is just what we have found to be the best overall kind of workflow. So I'm going to touch on a whole bunch of different topics today. A little bit about myself. I work heavily on the flying side, but primarily I'm on the data side. So I'm the lead photogrammetrist here at Aerotas, but I certainly work with our flight operations team, with our CAD team and line work team and all of that to know the big picture of the entire workflows, all the way from planning a mission to flying it, well heck, from buying a drone to planning a mission, flying it, and then getting to the final data at the end. And for me, working with surveyors and on the photogrammetry side, I care deeply about accuracy, right? That's one of those things that's going to be critical, and we'll talk a little bit more about accuracy later today as well. So just from a high level, the things that I plan to cover with you today, for starters, overall, like I said, it's a summary of the last 6-7 years of drone surveying knowledge. 6 years ago, this was a really nascent field, trying to apply the concept of digital photogrammetry to something that was collected by a drone was really intriguing, but ultimately the accuracy was kind of good. People were using it more for just some ortho photos, image backing on drawings. And then we started getting better and better with the accuracy, understanding how different cameras work a little better, the ways to integrate all of the data a little bit more reliably. So we're going to talk a lot about what drones can do, drone surveying, that sort of thing, actually extracting valuable data, but also the bigger question is what drones should do. A common pitfall that we see with a lot of surveyors is because a drone can do something, they want to apply the drone to that technology when there is a better technology to do it. For anyone that saw my LiDAR talk yesterday, I had a couple of slides where I was talking about when you shouldn't use LiDAR at all. And it's the same thing with drones too. They're a spectacular tool, they're very powerful, but they are not going to replace the surveyor, and they are not going to replace the other tools in your truck. And just because a drone can or is technologically capable of doing something doesn't mean that that is the best workflow or the best way to make a business out of it. We'll talk a little bit about that. We're also going to go over the kind of current state of the art of the hardware market. That'll be interesting for anyone who either doesn't own a drone, is looking to upgrade, and wants to know a little bit more about that. We're going to go over mission planning a lot. Mission planning is something that can very easily be overlooked, where you just send someone out in the field with a drone. But as I always say, an ounce of prevention is a pound of cure, and how 5 minutes in the office will save you a ton of time later down the line. And that means mission planning for us, we're going to actually go a lot into that. We're going to go over the different Autopilot softwares out there. We're going to talk about what the right overlap and flight altitudes are, how to get the right accuracy, and we'll even touch on the legal aspect as far as flying in restricted airspace. If you're doing a survey on an airport property, how we can actually get you there as well. And then we're going to go into the data processing best practices as well. Now, it's worth noting this is not going to be a deep dive into how to become a certified photogrammetrist overnight. As much as I like to think I'm a pretty good speaker, I don't think I can do that in an hour and a half, let alone a small subset of this presentation. The other thing that you see with every talk that I give is, if your drone program isn't saving you time and money, it's not working. That is because we view the entirety of these drone programs as business programs. This is not a research project. I'm not giving this talk at a university. They wouldn't like it. This is not an academic exercise of how to do something. This is how to create a drone program that is reliable, repeatable, and actually makes sense in a business, to scale it up, to actually use it on your project so it makes your life easier, makes your clients have better data, and it makes everybody happy and saves money and time. So with that, a couple of key things that we talk about when we say what a good drone program is. Well, for starters, a good drone program should increase your flexibility. That means that it shouldn't be a dead weight that you have to do. You shouldn't have to force yourself to use the drone. If you are figuring, it's like, I want to do this on the ground, and my boss says I need to use the drone or something, there's something kind of wrong with your workflow. It should make your life easier, actually, and make it more flexible. You should be able to cover way more land, whether it's a 50, 100, even a 500-acre topo. The drone should be able to make you give you the ability to get data that you wouldn't otherwise get. It should also be able to save time and money. Like I said, it should take less time in the field. If using the drone, you're finding it's taking you more time in the field, again, there's something probably that needs to be worked out in terms of your workflow to get it a little bit more reliable, a little bit more straightforward and smooth. This should be a very, very easy, reliable thing to do. And also, it should get you better deliverables. That means that you're not actually sacrificing accuracy by integrating the drone. In fact, it should be better. You can have that absolute up-to-date ortho photo with a perfect record of your site conditions. You should be able to use the drone data to double-check a lot of your field data to make sure that you didn't miss a couple curve shots, or, hey, there's an animal there that I forgot to shoot, or something like that. It should be able to provide that perfect, reliable model so that you have much more data than you did before, better than it was before. One of the ways to do that is avoiding many of the common pitfalls that we see. These are the pitfalls. Again, it doesn't make a drone program not work, but it makes it a lot less successful to the point where maybe you spend this money and realize it's not you're not getting the right ROI. For starters, like I said, don't use the wrong tool for the job. LiDAR drones are spectacular and should be used pretty much only in vegetated areas, not on hardscape. Drone photogrammetry is wonderful. It does great work with topo. It can do curve lines. It can do parts of an ALTA survey. But if all you're doing is boundary, it probably doesn't make sense to break out the drone. The drone cannot do a lot of the groundwork. It can't carry a shovel and dig up any buried monuments. But if you are doing topo over a 20-acre site, the drone is going to be the perfect tool for the job. And of course, all your other equipment that you have in the truck is still there and should be used for the right tool. So picking the right tool for the job is important. Drones are becoming more powerful and they can be used on more and more jobs, but they're still not right for everything. We'll go over a little bit more in detail what I mean by that. Also, don't overspend on gear you don't need. This one is where I can get in a little bit of trouble at these conferences because there are a lot of other hardware dealers out there, and I come and I kind of say, hey, they're selling you a lot more than you actually need. Especially as of a year ago, there were LiDAR drones that were well north of $100,000, and getting your return on investment on them was just impossible. So we're a big fan of keeping costs down a lot, and that when we talk about the hardware side, that's where I'll go into that, because we don't sell hardware, so we can very easily say we want to process the data, and what we know about hardware we learn from seeing the other surveyors out there, who's being successful, who's not, who's actually having a drone program that's growing because it's making them money, it is saving them time, and who has one where they say, spent all this money on this drone, so we gotta find a way to use it. That's a general sign that something has gone awry. But also don't spend too much time in the office. Let's say you are doing everything right, you're saving time in the field, you're flying the drone, and then you come back and your 20-acre topo is taking 40 man-hours worth of work to actually extract data on it. That's another sign that you actually have to get efficient about data processing, extracting only the data you need and getting a good workflow for it. And then lastly, I've said this before, don't treat this like a research project. This should be a business opportunity, not a research project, to actually get the data you need, get out, and then do it again. Part of my goal with drones and with working with this is to take this cool concept of flying robots and make it supremely boring. A good drone program is just like a lot of this other work stuff. You push go, it flies, it buzzes, it collects its data, and you go through that standardized workflow. It's not interesting, it's not crazy, you're not on the bleeding edge of, trying to make new things happen. It's a routine workflow, and that's a good thing from a business standpoint, is how to make it routine. So this slide, the drone surveying journey, shows where most people go. And I don't know where everyone is on this in this room, at least on this chart, but this is the typical path that we see most people do when they start working with drones. Many of them start with buying a drone that just takes basic photos and videos. Maybe it's what we would call even a toy grade drone, right? $100 or something with a little camera, or maybe a little bit more than that. Maybe you're spending $1,000 and you're taking site photos that you can document there and say, hey, photos, videos, great record of the site, very cool. And then they step up and start stitching it together into ortho photos, maybe using an buy a software online, use a cloud service, throw it together and get an ortho photo, and it looks really good. And then you start adding accuracy and precision to that, integrating your ground control points, translating it, managing your coordinate systems properly, maybe integrating RTK data or something. Then you start working in 3D, getting your digital surface models, your point clouds out of that as well. And then you start extracting that into clean CAD drawings and actually bringing those vectorized features, your curve lines, your polylines, your thin surfaces into CAD. And then you integrate it into a final survey deliverable. And the top of this pyramid, when you're really successful, is when you actually turn that into a repeatable workflow. A lot of people have gotten all the way to that second to last one where they have been able to figure out this journey, these steps to actually get an incredibly high quality deliverable from a drone, but then they become the only person in the company that knows how to do it, and they have to manage the whole process A to Z, and then they're buried with time because they have all these other things to do, and it's not a standardized, written down, repeatable workflow. That's the part that really turns it from a R&D project into a functional drone program. So this is the main workflow that we talk about when we say, use a drone workflow. It should always start with mission planning, which once you're experienced should only take a couple of minutes figuring out, okay, where's the job site? If you have multiple drones, what drone am I going to use? What flight altitude am I going to fly? When am I going to fly it? Checking pretty basic stuff like that. Then you go out in the field, collect your data, pretty simple. Process your photogrammetry and LiDAR data in there into those rich 3D models. Draft your line work on top of it, import it into CAD. This is what your standard repeatable workflow ought to look like. And at the end of the day, what you want is a final survey. That's what a good drone program should get to. Very, very few people ever want a drone survey. What the end client typically wants is a survey, and it's up to you, the surveyor, to figure out how to do that and what the right tools are for the job to get the client the data that they need. All right, so with that, I'm going to dive into the hardware side of things, and we're going to talk about the latest in drone hardware that's out there. And now, I should point out, I love questions. Especially when it comes to drone hardware, this is still a rapidly changing world. Different people have different experiences. So if you have any questions, please take a sip of coffee, get yourself excited, and ask me. I love having interactive clients. And part of it is, I'm here to help you guys. So if there are questions you have about hardware, I can at least give you, or really any part of this presentation, please do raise your hand and interrupt me, and I'd be more than happy to see if I can help you out. So, starting with drone hardware. The first thing I'd talk about is what criteria do we use as a company for evaluating hardware? For starters, accuracy is important, but not everything. The most accurate drone is not necessarily the best drone. The drone with the highest, most fancy, the highest megapixel, fanciest camera out there is not necessarily the best drone. Accuracy matters, but as I mentioned before, if you're overspending on accuracy you don't need, that's a problem. And especially if it doesn't work on the other categories, things like ease of use. Do you need 6 weeks of customized training in order to operate the drone, or is it something that you can take one of your more junior guys, you can draw a flight path on an iPad and push go? That's what we like. We like reliability of workflow. How often do you go out in the field, push go, and it just works? That is extremely important for us, for it to just work when you go out and not give all kinds of crazy error codes that require troubleshooting and again require very specialized knowledge to be able to fix it. And then also the cost is something that you need to think about. And not just the cost of the hardware, that is really important. The difference between a $3,000 drone and a $300,000 drone makes a big difference. But also the cost of operation. How many people does it take to operate it? And how much time does it take to prep the drone for a flight beforehand and pack it up and transport it and all of that? The cost of data processing. More complex drones typically have more complex data processing workflows, which can increase the cost and make people a lot more reluctant to use the drone on other projects. So we like to keep it very simple. And one of the other big splits in drone hardware is what we call kind of DJI versus everyone else. DJI is overwhelmingly the market leader in drone hardware. And generally speaking, DJI is very good. They have a simple workflow. They're some of the most easy to use drones. They are relatively cheap. That you can actually start with a survey-capable drone for about $1,500 with DJI. Really easy to use, and they have good, but admittedly not the best, accuracy. The downsides of DJI is they are Chinese-made. That is a major limitation for a lot of people, especially in government work. Their hardware support is nearly non-existent, and they aren't going to be the most bleeding-edge technology out there. Everyone else, of which there are many, many drone manufacturers out there, and no one has established a dominant second place in the market, they are typically going to be more specialized to your needs. They may or may not be made in the US as well. Some of them are still made in China. They often have better hardware support, sometimes more cutting-edge tech, but they almost always have a much more complex field workload. They're usually going to be more expensive to get the same quality of data, and they usually require a bit more specialized training. Now, I'm not giving generally speaking, we prefer DJI drones, mostly because of that ease of use side of things. But if you have drones from other manufacturers that you like and you work with, that's fine by us too. To go a little bit more into the kind of options of different types of DJI drones, what are some of the best ones on the market right now, what we call your entry level is going to be your Phantom 4 Pro right there. And we say these costs at the bottom are really your all-in costs after you account for all of the other accessories and batteries and stuff like that. You can get the drones themselves for considerably cheaper, but then you wind up needing all this other stuff that's expensive. So your entry level is going to be a Phantom 4 Pro. It's good enough for most land surveying applications. No RTK data, something like that. It's a great beginner drone starting for people that are just starting drone programs. Our favorite and best overall is this Phantom 4 RTK, about $12,500 all in. RTK enabled dual band GNSS receivers, really, really simple workflow and great reliability in a really small package without overspending. This is what we see that's going to be the most common drone that land surveyors use, that are used frequently, I should say. Although becoming more popular now is this M300 with the L1 sensor. That's a LiDAR drone. It's at 40 grand all in. It's cheap for a LiDAR drone, and is a very, very reliable system overall. It's becoming a lot more popular. Although admittedly, it's not only more expensive, it's considerably bigger than the Phantom series. So it's not as easy to just throw in the truck and go on every job site, but especially if you're here working in Western Washington where there are a heck of a lot of trees, maybe you need LiDAR. And if you need LiDAR, there is no LiDAR in a small package, at least not right now. So those are kind of the popular DJI drones out there. Other ones, yeah, question?
Does the Phantom 4 RTK work in a PPK workflow where you bring in external data?
Yes, it does. And we do a lot of PPK processing with it. Our preference, and I think I actually have a slide coming to this, our preference is to have a local base station to actually stream it in real time, because that gives you a lot more data such that if you're doing a PPK environment and you're relying on core stations, maybe the core station was down that day and you didn't know, and that can totally ruin your day. So we really prefer having a local base station, and the way that we actually do it, we use a local base station, and then we post-process all of the base station data too, so we get like an open solution on it. Anyway, there are multiple workflows. Thankfully, the Phantom 4 RTK does, and the L1 sensor, they both do expose the raw satellite data, the WiMAX data, for post-processing abilities. But that's a lot of work. I should point out other DJI drones that are out there are the smaller series, anything less than the Phantom 4 Pro, and that includes a lot of the Mavic Pro Enterprises, Minis, all of those drones. DJI has a whole bunch of drones that are very, very cool, but we typically don't recommend them for surveying. They are built for different purposes. They are built for cinematography, for being able to throw in your backpack and taking cool videos. And ultimately, they just don't have quite the level of camera that we use to actually get survey grade data. If you just want site imagery, they're great. They're wonderful drones. If you're filming yourself going hiking or wakeboarding or whatever, they're wonderful drones too. But for surveying purposes, these are the only ones we recommend, partly because of what's called they all have mechanical shutters on them, global mechanical shutters, which is a camera component that is required to get that 1/10 of a foot accuracy that we typically have. Any questions on DJI hardware? Just because I know it's a complex world out there. Yeah.
With the L1 sensor, do you find that data comparable to sort of more expensive, higher end, like USA-made systems?
Great question. The raw accuracy in terms of how tight the point cloud is slightly worse than high quality other LiDAR systems. However, it is considerably cheaper and has a considerably easier workflow. Those are going to be your trade-offs there with the L1 system. Comparing it to, for example, there's some microdrone LiDAR systems out there. The microdrone systems have better quality data. They just do. But they're a lot more expensive and they're a lot more difficult to operate. The L1 system, I can put it in the hands of someone with 2 hours of training and they'd be able to go out in the field and reliably get good data out of it. And this is where I say don't overspend on data you don't need, because the L1 is typically good enough for the overwhelming majority of surveying applications. Because it has a photogrammetry sensor on there as well, and the photogrammetry sensor can get you a 1/10 of a foot accuracy in hardscape. And that LiDAR sensor, which it collects data for both at the same time, the LiDAR sensor can get you usually about 2/10 of a foot accuracy in dense vegetated areas. That is almost always going to be good enough that you can get 2/10 accurate topo data with extremely high resolution over an entire job site. That's usually good enough for most people, especially when you're still getting that 1/10 of a foot on hardscape from the photogrammetry workflow. So, those are kind of your trade-offs. Is it the best sensor out there? Absolutely not. Nope. But it might be the most reliable and the best for your use cases.
So that second system you mentioned, what kind of accuracy would you expect on that system for LiDAR? And then if you could also expand on what do you mean by more difficult to operate or workflow?
Great question. So, when I say better, the LiDAR accuracy we've seen is good as about a 1/10 of a foot LiDAR accuracy on some of the higher quality ones, versus about 2/10 of a foot vertical accuracy is what we're seeing on the M300. When I say more difficult workflow, the M300, you turn that on, you kind of turn the base station on, the lights all go green, and then you push fly. That's what we consider a simple workflow. A lot of the other systems are much more bespoke. You need to power on the LiDAR unit, you need to power on the drone, you need to make sure that the IMU is initialized, you need to then turn on your own base station, you need to set it up broadcasting in an end-trip environment, you need to then make sure that it is connected and being received by the other thing. There are just a lot more moving parts, and the software is not quite as just user-friendly, right? That there are a lot of different things that might not work properly. You know, I'm getting this error, it's blinking 3 yellow lights. What does that mean? It means I need to recalibrate, blah, 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 blah. It's just a more confusing workflow. And what we see is that it's not dangerous. All of these drones have become unbelievably reliable, which is wonderful. But what we often see are things that just kind of go wrong. They fly the drone, and for whatever reason, the camera trigger mechanism wasn't working properly, so it flew LiDAR, but there's no imagery data, which means you have an uncolorized point cloud and no photogrammetry. Do you go back into the field? Do you fly it again? Those are the time killers that we really hate. When it works, the data is better. When it works. But it more often doesn't work than these other things. And to get it to work reliably, you need someone that's really, really, really well trained and familiar with it. And to get that familiar with it, they typically get that way by making a lot of mistakes. And that's a really costly process. So those are the trade-offs that we see there. And again, if there's someone in here that has some of these systems and it's working for you, awesome. Do it. Keep using it because the data is good. But the learning curve to get there it's a expensive and longer path than with the L1, which is a little bit more just easy to use. Does that answer your question? A little bit more on hardware just to talk about here. There are multiple different airframe types out there, especially when we're going outside of the DJI ecosystem. Generally speaking, you have your small multi-rotors like the Phantom. There are some Autel ones that are similar-ish in terms of their quality. Your larger multi-rotors, those are going to be your M300, your micro drones, or a lot of other bespoke aircraft that we would classify as larger multi-rotors. Small multi-rotors like the Phantom, around 4 pounds usually and $5,000. Larger multi-rotors, 40 grand plus, about 30 pounds, considerably bigger, a lot bulkier to move around, just kind of a bit of a pain, but when you need them, they make good data. And then we haven't talked too much about fixed wings. Fixed wings have fallen out of favor a little bit just because multi-rotors are so darn easy to use and flexible. And actually, multi-rotors are used on very large sites too. We've seen them up to even a couple thousand acres. But fixed wings are very good if you regularly cover extremely large areas. When I say extremely large, like well over 200 acres. If you're doing multiple 1,000-acre topos a year, maybe a fixed wing makes sense for you. They have very long endurance. They can often fly for an hour by themselves, but typically they have to fly at higher altitudes. They can't do your half-acre site or your 5-acre site just because they require so much more airspace to fly. The Sense-Fly ED or Wing Turtle ones are both examples of that. They typically get actually very good data. Probably should update this. Their accuracy has been better over the last couple of years. Totally useful, but usually overkill in most circumstances is what we've found. But the data that they collect is perfectly acceptable and totally good. Yeah.
So are any of them, I mean, we talked about acres, so I mean, I'm thinking like square kilometers, so acres, but if you're doing like route surveys or something, are any of these more advantageous for like the distance away from you that you can get to?
You run into legal issues there.
Oh, is that?
Yeah, so there are regulations that the drone must stay within visual line of sight of the operator, which means that all of these drones, including the multi-rotors, are capable of technologically capable, sending them 5 miles away and then coming 5 miles back. But that is not allowed by the regulations. So typically what we see is with any of these, you can do about a 1 mile stretch at a time before you have to pick it up, drive down, do another launch point, and then do another 1 mile corridor. So that's about what you can do in practical purposes. But they all work with corridors, and the multi-rotors, again, are typically going to be advantageous just because they're so much easier to take off and land. You were asking about GNSS options. Most of these RTK drones have different GNSS options. Your basic drones have no RTK whatsoever. They have rudimentary GPS on them, about as good as your phone. It is the most affordable and really simple, reliable workflows, but you have to set a lot of control points in the field. With RTK data, once you do start having dual band GNSS receivers on the drone, there are a couple of different options. You can run either PPK off of known base stations, core stations, anything like that. RTK with a local base, which is going to be very high precision, or RTK based off of an internet connection or a cell connection. I think Washington State has one as an NTRIP system. Our favorite is RTK with a local base. That really is just the most reliable workflow. And of course, if that fails, you can actually fall back and run PPK processing as well with any of the other different corrections. But our favorite is RTK with a local base. It just provides the most precision, having effectively zero distance baseline processing for any RTK corrections. It leads to the highest reliability and accuracy workflow, but the other ones do work as well. And this is another great example of one of those things where there is no perfect right answer. You can do RTK with an internet connection, and a lot of people do so successfully. You can do it with only PPK, and a lot of people do it successfully. But in our experience, the best overall is with RTK with a local base because it has that higher level of precision and higher level of reliability. Yeah?
I always feel a little hesitant with those DJI RTK systems because they come with a DJI RTK base station, and it doesn't seem like a company that I want to trust for GPS grade, or GNSS high quality survey data. Like, have you had, in your experience, how do those DJI branded RTK bases compare to having like your system run through like a Trimble base station or something?
Great question, and the short answer is good enough. We use those DJI DRTK2 base stations purely for the drones. We would not use it for surveying, partly because a lot of the other ancillary hardware, the actual like pole that it mounts to, the leveling bubbles are all fairly low quality. All you really care about with that is that it is fixed perfectly stationary, and then it's streaming the corrections from there, so that the drone itself has, when you do process it with that, has extraordinarily high precision being relative inaccuracy there. And then you get your final accuracy by localizing it with ground control points after the fact. That's what we have found in our experience with that DRTK2 base. So is it as good as Trimble equipment? No. Is it going to be something that I would recommend the surveyor use instead of any of their other GPS? Absolutely not. But it is, like a lot of this other stuff, super easy to use. It has like 3 buttons. One of them is the on button. You turn it on, set it up, and then don't touch it, and it works. That's why we like it so much. So no, not highest quality GNSS in the world, but it is great for its application, which is just streaming local corrections to the DJI drone. And then lastly, talking about LiDAR drones, I did give a talk on LiDAR drones yesterday, I should point out. If you weren't there and you want to see it, you can shoot me an email, logan@aerotas.com, and we have a video recording of it we'd be happy to send to you if you're interested in a deeper dive into LiDAR stuff. So, LiDAR drones work best in vegetated areas. They provide very good ground data in forested, treed, vegetated areas. 2 to 3 tenths, actually even a lot better than that is what we've been seeing recently. But you want to use a blended workflow because photogrammetry remains more accurate on hardscape than LiDAR. All of our data has shown that for aerial LiDAR across even some of the best systems that photogrammetry remains higher accuracy than the LiDAR data on hardscape. And good workflows make all the difference. So LiDAR drones are very good in vegetated areas. If you're doing a lot of topo in the woods, LiDAR probably would make sense to you. If you are not, especially if you're in eastern Washington and you don't have an insane amount of trees, photogrammetry is still going to be a much more affordable, much more reliable workflow there. So our overall favorite setup is the Phantom 4 RTK, right? That is our favorite. We find that to be the surveyors that are most successful and that use these drones the most and have the most high quality data are using the Phantom 4 RTK right now. It's a great drone at a reasonably good price, around, like I said, 12 grand all in. And that one's just our favorite. If you have other drones, like I said, those work too. We process data from absolutely everything, and we see people who are successful with very, very different drones, but this is overall our favorite setup. All right, any other questions about hardware before I dive into some of the mission planning stuff? Cool. All right. So let's talk about mission planning next. Now that we assume we've got our drone, what's next to actually be successful and to actually have a profitable drone program? Well, it's mission planning, and that's asking yourself questions like, is this a good site for drone photogrammetry? Is it legal to fly here? What altitude should I fly? What is the appropriate overlap? How many control points? Where do I set them? How do I arrange the flight pattern? And what data still needs to be ground surveyed? For anyone that is an experienced pilot, these questions are pretty easy to answer, and that's what I'm going to go over for the next good chunk of time. But why care about mission planning? Short answer is, well, one, it will save you a lot of field time because you can set fewer control points. That means less time if you're out in the field. Less ground surveying because you know the things that the drone's going to be able to capture, so you don't need to do as much field work. Shorter flight times and no field revisits. That's the big time saver right there, is making sure you don't have to go back out in the field. But it also does save office time. If you collect the data properly, it makes your processing time shorter, it gets you better accuracy, fewer errors, and overall a simpler workflow. So we really care about mission planning. In fact, in our experience, about 2/3 of the errors that we see in photogrammetric processing actually come from poor mission planning. So if you're struggling with photogrammetry, there's a good chance it's not even that you're a bad photogrammetrist, there's a good chance that the data was just not collected in a way to set you up for success. So we are big fans of making sure that your mission planning, your overlap, all of that stuff is set appropriately. So for starters, is this a good project for a drone? Well, they're size-wise, 1/2 acre to 500 acres typically makes sense, up to about 1,000 before you would really want to consider hiring a manned aircraft to cover larger acres. And smaller acres or smaller sites under about 1/2 acre, you might want to consider just doing that on the ground. Up to about 20 miles for a linear corridor. We've actually gone a little bit longer than that as well, but again, this really depends on your exact workflows when it starts making financial sense to hire a traditional aerialist with an airplane that can fly a 100-acre corridor in a day. You can't do a 100-mile corridor in a day. You can't do 100 miles of drone work in a day, but if you're doing it in phases, then maybe the drone makes sense. Low to moderate vegetation, or it actually can do dense vegetation now with LiDAR, but photogrammetry, if you have a photogrammetry drone, can't do dense forests. It just can't. LiDAR can. Wonderful for topo mapping. We use it for ALTA surveys, at least for major components of ALTA surveys. If any of you are aware, ALTAs have to be, I think you have to walk the boundary on the ground. The drone can't do that, but it can do a lot of it. It's great for planimetrics, finding utilities, drafting your curb lines, that sort of thing, volume calculations, etc. Bad projects are, like I said, your very, very large ones, north of 1,000 acres or something, as well as extremely high accuracy tolerances. If you need better than 1/10 of a foot accuracy, a drone's going to be the wrong tool. You got to break out the total station for that. Indoor, underneath overhangs, underneath trees, things like that is where the drone isn't going to be the right tool for the job. All right, next up, let's talk about some safety and airspace restrictions. The FAA was big on this a couple of years ago, and it's kind of fallen back that a lot of people haven't paid very much attention to all of the changes over the last few years of FAA Part 107 rules and where you can and cannot fly. But we have, so I'm happy to give you kind of the updates on this. Anyone that has their Part 107 license has probably seen this chart. You're allowed to operate in Class G airspace without any permission, and operations and everything else, B, C, D, and E airspace, are only allowed with required air traffic control permission. Thankfully, the overwhelming majority of airspace is just open. In fact, 99% of the United States, at ground level, which is what we care about, is Class G uncontrolled airspace. So 99% of the ground you can actually fly without any FAA permission whatsoever. But many projects are within controlled airspace or near airports. The one thing that we always like to say is you actually can fly in any controlled airspace. With this new LANC system that the FAA has, you can get instantaneous approval to fly in a lot of places very near airports. And then going beyond that, you can still actually fly in ones where you don't have instantaneous LANC approval with the proper paperwork. So LANC for most controlled airspace, manual authorizations for all other. Depending on the job site, it may make sense to file the paperwork to actually do it. We have helped a lot of our clients get authorization on the most restricted airspace, whether that is actual airport surveys on the airport property, which takes a little bit more paperwork because you have to coordinate with the airport that they know not to allow any planes in and out while you have a drone literally on the runway. We've done runway surveys regularly, actually. And other ones might be a little bit easier and quicker. So it's the type of thing that you can actually fly a drone anywhere. The only question is how much paperwork you have to do, and that's something that we help a lot of people with. Waivers and authorizations, like I said, LANC is a system for instant airspace authorizations. I think our favorite app is one called Kitty Hawk now that allows you to just download, or it has a different name, I don't really remember that, but you can get your instantaneous airspace authorizations really easily. The manual airspace authorizations take time, and if any of you really love the nuanced legal regulations of it, there's another system called a waiver that you can get that we would just strongly discourage, but I'm not going to go too deep into that right now. It's also noted there's a difference between the FAA authorization zones, where you legally can and cannot fly, and then the DJI no-fly zones, which is where the drone geofences you to say you can and cannot fly. So the way that works is if you took a DJI drone and set it on an airport property and tried to hit fly, it would not take off. Well, for bigger airports, at least really small ones, you might still be able to. But it wouldn't take off because they geofence it, they try and protect you from yourself. It's just worth noting that these are different things. There are places where the FAA says you can fly and DJI says no, and vice versa. Sometimes DJI will let you, the FAA can. All of this can be very easily managed, honestly. You just have to be aware that this is a thing. And sometimes, if you're flying near an airport and the drone's taking off, and you say, hey, I have FAA permission, there are just a couple more check boxes you might need to do to actually get authorization to unlock the drone so that it can fly in controlled airspace. Flying over people, this is an interesting one as well. So technically, you may not fly the drone over other people unless those people are participating in the operation of the aircraft or located under a covered structure, blah, 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 this sort of thing. These are what the technical rules are as far as flying over people goes. But what we often say is flying drones in the real world, the FAA is, and when people ask about, oh, is it legal to fly here? The FAA is looking for bad actors. They're not trying to catch people on technicalities. What I would always say with this is, if there's an outdoor concert, don't fly your drone over it. That would probably get you in trouble. If you are flying over a rural highway and there is a car on the road, absolutely that is fine. And it is extraordinarily common, and in fact we're likely to see updates coming in the near future about changing a lot of these regulations given the extreme reliability that these drones have and the very, very little danger that they pose to anyone. But we always say just operate responsibly and use your good judgment. If it seems like a dangerous place to fly a drone, then don't fly the drone. But as far as the FAA, FAA has no police force. They're not trying to look out or trying to get people on technicalities. They're really looking after malicious actors that are trying to intentionally disrupt airport operations or pose a danger to public safety, things like that. So that's our kind of take on safety. Questions there on the legal side of things? All right. Let's talk about some of the autopilot softwares out there. For those of you that are aware, drones, especially in the survey realm, fly themselves. You plan a mission and you hit go. That's all there is to actually flying a drone. It's very easy. You don't need to have a lot of pilot training. You don't need to use thumbsticks at all to do it. A lot of people do use the thumbsticks to fly around, take site photos, take pictures of their cat, whatever. That's totally fine. Cats and dogs typically really hate drones, by the way, just an FYI. My dog doesn't like it when I fly. But most of them fly using an autopilot software of some form. There are a ton of autopilots out there, and people regularly ask, hey, what autopilot do you use? Which one's the best? And honestly, they're all very, very comparable in our opinion. We have no strong preference on this. If you're using Litchi or Pix4D Capture or DJI Pilot, some of the newest DJI ones, they have the autopilot baked into the controller, so you don't actually have a choice. And those ones are totally fine as well. They actually all work, so if you have a preference, go for it. Our general preference is to stick with the first party one, so DJI, using the DJI Autopilot, that's generally our preference. But if you have any other preference for yours, great, keep using it. It's not worth changing if it's getting done what you need to do. They all kind of work pretty similarly. The only slight difference is with terrain awareness. Terrain awareness is where the drone more or less follows the terrain. So for example, if you're working on the side of a mountain and it goes up by 400 feet, you want the drone to generally follow the side of the mountain up. That is available in most of the DJI autopilots that come on the controllers as well, and it really helps with accuracy and reliability on larger projects. When we say larger in this context, more than 50 acres that have significant elevation change. Significant to us means more than about 200 feet of elevation change on a single project site. That's when you're going to want to start using terrain awareness. If it has less than that, probably don't need to use terrain awareness because it just adds a layer of complexity. The way the terrain awareness works, for those that are familiar, the drone doesn't actually track the terrain. It doesn't see where the ground is below it. What you're doing is importing a model of the Earth. It's a low resolution model, typically from what's called SRTM, that basically it's Google Earth elevation model effectively, and it just kind of follows that so that it follows the rough terrain of what it thinks is there, so that when you're going up the side of a hill, it raises altitude as well. And it's very functional, like I said, it helps, but autopilot specific. All right, next up on mission planning is talking about overlap and accuracy. So when we talk about accuracy, overlap, and actually flight altitude as well, one of the things that I always say is you want to start with your desired results. One of the biggest time killers that we see is, hey, let's just fly the drone and see what we can get out of it. I say, can you imagine sending a crew out to the site with some tools and just say, let's see what data they get. They're not going to get what you need. You need to know what you want first and then go for it. So when choosing your flight accuracy, I probably should reorder this. You should start with what's the accuracy that you actually need. And then from there, you can go back and say, all right, well, what flight altitude should I fly for that? If you need better than 1/10 of a foot on armscape over everything, then you should probably be flying 150, maybe 200 feet above ground. If you're okay with around 2/10 of a foot noise or 3/10 with LiDAR, which is very, very acceptable for topo jobs, right? If you're doing 1,000 acres and you need 1 foot contours, you ought to be flying at 400 feet. Because the other thing where this comes in is the amount of coverage. You can cover way more area at 400 feet than you can at 150 feet. And the other thing in here is the amount of data that you're going to generate. When you fly at 400 feet, you generate a lot fewer photos, and it's so much easier to process, and you need fewer ground control points actually too. So 400 feet is going to save you so much time in the field if you don't need that accuracy. Now, a lot of times you need that accuracy, and that's okay. So usually we actually find kind of 200 to 250 feet is really the Goldilocks zone for most job sites that we find. And these are a lot of, up to about 20, 30, even 50 acres or something, flying 200 to 250 feet is going to be a really good middle ground for most of these things. Very efficient, doesn't take too much time in the field, doesn't get you overkill in terms of the data, but still gets you very good accuracy. If you're only ever doing 5-acre sites, fly it at 150 feet, it'll get you the best resolution imagery, the best accuracy. If you're doing 100-acre topos all the time, fly at 300 or 400 feet, that'll save you the most time, save you the amount of data, and actually winds up getting you better accuracy. So one thing that is a common misconception is that when I give this chart, does that mean that lower altitude is always better? It actually doesn't, because when you're doing really large sites and you fly too low, it's something that I call the drinking straw effect. It's like trying to survey by looking through a drinking straw. Each photo has such a tiny footprint of ground that it can see that it actually makes it more challenging mathematically to interpolate the thousands and thousands of photos, so you actually lose accuracy when you fly too low on large sites. Flying higher, counterintuitively, can get you better accuracy on those larger sites. And again, that's your 50, 100-acre plus ones where flying higher can actually improve accuracy. Questions there? I know this is always an important one. Yeah.
Is there a combination flight height? Like, I mean, do you fly the drone at 400 and then do some smaller areas at 200 feet, or is that?
That is possible, and very rarely is that needed. Usually that's kind of a waste of time without getting you too much accuracy. The only exception to that is, let's say you're doing a 100-acre property and on it is 5 acres of developed land and hardscape. You might fly the entire 100 acres at 400 feet and then do a second flight only over that small subset with higher accuracy. So yes, in that circumstance, it does make sense.
So then do you integrate, I mean, you as the data, do you take the 400 foot or the higher elevation one, run that first and then run the smaller model inside that, or do you do them separately, or is they?
That's a little project specific. We might do them fully separately and merge everything finally only in CAD. Alternatively, you actually can process all of the data together in a single photometric block. That has some different challenges associated with it because you have such varying resolution. That can create some artifacts in the ortho photo. So it's a little site specific. Either workflow actually works, and that's where kind of the experience of running a lot of photogrammetry can help guide you to which one's going to be the best option there. But typically, the answer is yes, you can do that. It just takes a little bit more work. Yeah?
Does weather conditions affect basically your whole planning to do, say, aerial survey?
Yeah, great question. So when talking about weather, there are a few things that mean you can't fly. One is going to be really high wind. When I say really high, over about 20 miles an hour, you shouldn't fly, and that's going to be a safety consideration, not even a data consideration. And then also there's precipitation. If it is actively raining or snowing, you're not going to get great data. Yeah, there are some safety concerns there too, but also when it takes a picture, it's actually going to see much of the rain falling. Some of the water is going to get turned into mist by the propellers, get on the lens, and that's going to cause low quality data. So you shouldn't fly during when there's active precipitation. Now, I know it rains a lot around here, but we do a lot of work around here as well. It doesn't rain 24/7, 365. We've seen it regularly. People go out to the field, they'll shoot stuff on the ground while it's raining, and when there's a gap in the clouds, they'll run out, push go, and fly the site and come back. So that's kind of your weather implications. Beyond that, people often ask about, okay, well, what's the best time in terms of cloud cover, what time of day, all of this stuff in order to fly photogrammetry. And the real short answer is, whatever time of day you're out there is the right time of day for photogrammetry. Now, if you were this academic perfectionist, the answer is high noon with perfectly overcast clouds. That doesn't happen too often because you want really, really bright, no harsh shadows, and exactly high noon to get the most light and the beautiful, even cinematography lighting out there. But that's not how the real world works. You don't always have that. And sometimes you have to fly early in the morning or late in the evening, or there's really bright shadows, or it's not super great lighting. And the answer is you can still make it work. And yeah, there are some implications there, but they're really marginal, right? If you run your analysis after the fact, it's like, oh, well, we could have gotten 0.08 of a foot accuracy, but instead we got 0.09 because there were some shadows that caused a little bit of artifacting. And that's where we're like, yeah, come on, this is about a business program. So lighting, yes, perfectly overcast skies are great. They will make the most pretty ortho photo out there. But this is the real world. Lighting conditions change. Cloud cover is unpredictable. You got to do what you got to do, and the data is still plenty good enough under almost all lighting conditions. Yeah.
On top of that, say there's no ground, right? And you go up 400 feet, and there's like a 50-mile wind. Does the drone account for that?
Mm-hmm.
Will it show you?
Yep. Depending on the drone, some of them will say what the wind speed is, that it can actually measure it, it flies accordingly. And wind doesn't actually impact data quality at all because the camera gimbal is so solid that even if the drone is kicking around like crazy in the wind, that camera stays rock steady, pointing down at the ground. Yeah.
You see better accuracy with autofocus versus manual focus?
Yes, autofocus is generally better. There are some exceptions. Because sometimes the autofocus doesn't quite work right when you have a flight with a whole set of images that were all out of focus, which we don't like. Unfortunately, it seems one of DJI's newest cameras, the P1, it's a very high-end, expensive camera. We actually really don't love the P1. We found it has a lot of glitches to it, including it has some problems with the autofocus that we've seen some large sites that are taking with all the images out of focus, which is not fun for something that expensive. But typically, keeping the camera settings at auto are going to be your most reliable thing to just have it work. When you start tinkering with the settings, that can lead to oftentimes having the wrong settings fixed in there, the wrong exposure value, the wrong autofocus, and then everything is slightly off. It's, again, that reliability workflow. Auto settings typically are going to be correct for almost all circumstances. All right, keep it moving through here on autopilots at least. There are a bunch of different types of flight pattern out there. These ones are screenshotted from the Pix4D capture app at least, but most of them have their own ways to do it. So manual flight is flying by just using the thumbsticks going where you tell the drone to go. That is not going to be sufficient for drone photogrammetry because you can't properly get the right overlap. Then there are single grid missions like this, a single style lawnmower pattern back and forth. Double grid missions where it flies one pattern north and south, and then a second pattern east and west, kind of a crosshatch. What these ones call for 3D models, which, by the way, we really hate that they call it that. They say it's for 3D models. We think a single grid is absolutely good enough for the overwhelming majority of surveying projects. Double grid data is complete overkill. You don't need it to get good data. It greatly increases your processing time without increasing your accuracy. We've actually done a lot of tests on this too of what the final accuracy is. That double grid is unnecessary for surveying missions. Single grid is better, and it kind of bugs me that so many of these apps recommend this because then we have to deal with the processing all of the data. When you double the data, it's not many, it quadruples your processing time when you double the amount of data. So I really don't like that they all try and say, oh, double grid, just take twice the data. Just take twice as long in the field and 4 times as long processing your data in the office. And it's like, well, yeah, because you're not having to do this. No, fly single grid. It's going to be a much more efficient workflow overall. Way more efficient. Then there are linear missions where you can fly that follows the drone along a linear corridor. Those are really great that most autopilots carry that as well. And like I said, terrain awareness, where it has a model of the Earth and it kind of follows the terrain. Those are all your different flight patterns, and all of them are totally acceptable. As far as the overlap that you set, this one is kind of nice that over the last few years, the drone industry has come to a more or less consensus that right around 75% overlap is the proper level for digital photogrammetry. Some people recommend a little higher, some people recommend a little bit lower. But 75 is the general consensus of you have plenty of overlap in case one of the photos doesn't take properly, it doesn't write to the image, one photo might be out of calibration, there are some changes in elevation that you weren't aware of so that you have proper overlap at the high levels without going crazy on the overkill that makes you have to process too much data. And on LiDAR, we recommend 60 to 65%. That's a little bit higher than most other people recommend for LiDAR systems, but we like it because it allows you on many sensors to run LiDAR and photogrammetry simultaneously, still get very high quality data, and have some redundancy for areas that might be obscured either by buildings or dense vegetation that you get better penetration. So That's our recommended overlap. We see a lot of projects with insufficient overlap. When you look at a flight pattern like this, there is not enough overlap in places like this. This would be what we would call bad mission planning. And then they have areas where they have like 4 flights or something. So this one is just an example of, you want to make sure that you have at least 3 flight lines usually covering it. Meteor versus oblique imagery. Meteor being straight down vertical imagery, oblique being at an angle. Best practices here is going to be Meteor only, all straight down imagery. And part of that is because when the drone is looking straight down, the camera actually covers out at an angle. It's almost, most of these drones now have about an 85, 90 degree field of view. So that means it actually is looking down at the edges at about a 45 degree angle. If you tilt the drone up, what actually happens when you have these obliques, as you get closer to the horizon, your resolution, your actual ground sampling distance gets considerably worse the closer you get to the horizon. Your resolution of what you can see on the ground is lower when you tilt that camera up. So what it winds up being is a lot of these oblique imagery suggestions do actually lower the accuracy that you get, while simultaneously increasing the increasing the number of photos that you have to take. So in our experience, Meteor only flights are going to be the best for the overwhelming majority of land surveying applications. I say overwhelming majority, the only time where obliques actually start making more sense is if you are mapping, for example, the facades of buildings. If you need much more high detail on the facades of buildings, you need to know where the vertical windows are located. Those are circumstances in which actually having oblique data would start to make sense. But again, that's rarely what you guys are actually doing, is telling people how high their windows are. And for that reason, or the other thing actually, I know just why this exists for other applications, some people want 3D models that they're going to put into a virtual environment, into a video game or something. In that, you want the sides of buildings to have really crisp, cool models with really high quality imagery. That makes sense. In those circumstances, then yeah, you might want high oblique imagery, you might want double crosshatch patterns. But you guys aren't developing video games, you're surveying, and that means that Meteor imagery is going to be the most efficient for pretty much all projects. Yeah?
Question back to your terrain mapping. You've got a site that has maybe in one corner it's got a bunch of 140-foot trees.
Mm-hmm.
What is just putting it on autopilot and letting it go? What does it do with those trees?
What, in terms of fly above them?
Okay.
So the short answer is this is part of why we recommend a minimum flight altitude of 150 feet, is because there are very, very rare circumstances where you're going to have 150-foot tall trees. And that adds a level of safety buffer. Same thing, there are very few objects at all outside of TV radio antennas and some high voltage transmission lines that are actually going to be above that. So that's a good safety level too, is that 150 feet. Most drones do have object recognition awareness, so hopefully if they will be able to see a tree if you didn't plan something right and stop and not crash into it nowadays. The way I like to view those systems though, that's like the airbag on your car. You're very glad to have it, you hope to never use it. Because they're not perfect either. So good mission planning, you should be able to see anything that is above 150 feet, should be plainly obvious. But yeah, 150 feet gets you above pretty much all obstacles out there. And if you are worried, fly high. Put it at 200 feet, that helps too. All right, so just a brief summary of some of the best practices for actual mission planning there. Single lawnmower flight pattern is the best, 75-75 overlap with Meteor and no obliques. And I mentioned this a lot before, but there is such a thing as too much data. Reducing the amount of data that you collect in the field will make you so much happier when you are processing it later down the line. It can take, if you collect too much data, it causes more time in the field, longer processing time, more numbers of files, and actually can even cause erroneous matches, whether it's that drinking straw effect or a lot of other issues that can come out of it. So fly higher when you can. You don't need the accuracy, fly higher. Single lawnmower, not cross-hatching, no overlap overkill. 90% overlap is not correct, pretty much ever. That is too much data, it doesn't help you. So, All right, next on mission planning is actually setting and managing your ground control points. For starters, I like to talk about RTK data here because that, whether you have RTK data or not, is a very, very, very big component in how many ground control points you need to set and where you need to set them. The last probably year or two, we've started to see a shift that we are seeing much, probably over half of surveyors now are using RTK-enabled drones as opposed to 2-3 years ago when it was very few actually had. The technology's really started to be adopted a heck of a lot more. And I should point out, RTK reduces the need for GCPs and checkpoints, but control and check data is still required. It is a terrible idea for any surveyor to not have ground data. This is one thing that I will gladly knock on a lot of the hardware salespeople or distributors and say, oh, you fly this, you don't need ground control at all, which is ridiculous to me because there are so many things that can happen, ranging from just blunders in terms of getting your vertical data wrong and having that off, to the fact that RTK data, even when it works perfectly, and which it most of the time does, it's very reliable, it gets you the location of the drone to about 2 centimeter precision, not the location of the ground, which is what you care about. And in between that drone and the ground, there is a camera and an image sensor and a camera lens. And those are not laboratory grade, perfectly precise instruments. So even when you have perfect RTK PPK data, the ground surface, depending on the exact composition of the lens, the focal length that you're using, can actually vary kind of significantly by up to a couple feet in many cases, because these aren't laboratory grade calibrated lenses. You recalibrate them in the photometric process. So short answer is, we say always have ground data. Even if it is just check data to verify it, as a surveyor, we think it is completely irresponsible to fly a drone and not have any ground control or check data whatsoever. Also, ground control and check data helps to make you localize your project to whatever data you're using on the ground. If you localize to just a known point that you found, and then you set your control points, it makes sure that your drone data lines up perfectly with your ground data. So we love control, and we think it is absolutely a necessity for pretty much everything. But how many ground control points do you set for RTK? Like I said, no control is not good enough because of the camera issues, localizing your project, and detecting errors. We recommend a minimum of 3 ground control points per project when you're using RTK data, plus an additional control point every time you change a flight battery. And that's just a rule of thumb, so that if you are flying really large sites, you shouldn't be using, if you're flying 1,000 acres, 3 control points is definitely really, really low on the recommended side of things. We can make it work, but we don't recommend it typically. For non-RTK, you need to set considerably more control points. Rule of thumb is about 5 targets per flight battery that you use. With non-RTK, you really need to have good distribution, control points in the corners, 1 in the center, something like that. When you do have your RTK data, the distribution becomes less important, considerably less important. And that's nice because a lot of times you only have access to one side of a project site when you have larger sites. Maybe there's a road going along it and you can set your control along there. RTK is very nice because having that control still lets you run your check data, validate everything, but then you can actually interpolate much further away. You don't need perfect distribution along the site when you are using RTK data. It's nice to have. If you have access to the site, I would recommend setting them well distributed, but if you don't, that's much less important. Also, you want to make sure the drone flies on the outside, at least one photo on the outside of the control. Setting a control point, right there or something, outside of the flight lines, not generally recommended. All right, questions on ground control points? Cool. I'm going to go into briefly into some advanced workflows before we then go into the office side of things. First off, large project planning considerations. So a lot of you are probably considering or have flown very large projects, over 100 acres or something. So what is a large project? Pretty much anything that requires multiple takeoff locations, which means it's going to be over 100 acres or greater than 1 linear mile. And basically one of the ways to do that is just move takeoff locations. Right? You were asking about, is a drone capable of flying 5 miles. Technologically, yes, it is capable, but for a handful of reasons, you want to just fly along 1 mile site, change batteries, drive to the next one, fly another mile. That allows you to have visual line of sight of the drone. You can actually see it. You have a better controller radio link beyond about half a mile in any direction from the operator. You start getting a much lower quality signal in terms of the actual video of the drone, that sort of thing, as well as terrain changes, being able to monitor major hills, changing your takeoff locations is just going to be a little bit easier for these larger project sites. So this is an example for a long corridor mission, how that's going to be your half-mile radius circle, I believe. So you can fly 1 mile there, change takeoff locations, another mile, etc. This one says 1,500 feet is about the limit you can see a small drone. We're typically comfortable flying up to about 2,500 feet in either direction from the pilot. There you go. Good eyes want to push your limits. So usually about a mile maximum from a single takeoff. And the thing that's interesting about this is that it's the same whether you're using a small multi-rotor or a fixed wing. And that's one of the challenges with fixed wings is that while they are capable of flying a lot longer, for those radio link and technological reasons, you really can't take advantage of a lot of that benefit. It'll be really cool if there's a day when you can set up a drone with maybe a cell connection to just automatically fly a 15-mile corridor up and back all by itself while you sit in the office. That would be cool. The hardware is capable of doing it right now, but the workflow is not capable. The legal side of things, the radio communication links are not quite there. Yeah?
So you're saying you're doing like a 3-mile section highway using a fixed wing. You can't use FPV to cover that 3 miles.
FPV is explicitly not in compliance with the law. Now, I'm not the police. I'm not telling you what to do, but using FPV, also known for those unfamiliar, first-person view, those are like the goggles where you're actually looking through a camera that is broadcast from the drone. That does not comply with any of the Part 107 regulations, and also is pretty much only available on custom-built drones. None of the surveying drones that I have here have any sort of FPV system. A couple caveats to that, but not really important.
When you're saying 2,500 feet, that's without any like binoculars or any, can you use binoculars to increase your distance, or is that?
So, I'm not a lawyer. I hope no lawyers are going to get mad at me. The legal answer is no. The wording of the law is you must be able to have maintain visual line of sight with the drone, unaided by anything other than glasses or contact lenses or something like that. That is what the actual law states. You are allowed to, but if binoculars are required to see it, then that is not sufficient to comply with visual line of sight regulation. Again, I'm not the police here. A lot of it is use your good judgment. If you have a site where you really need to go 3,000, 3,500 feet away and you want binoculars to feel good, do it. I'm not going to get anyone in trouble for that. But the letter of the law is visual line of sight unaided by anything other than glasses or contact lenses.
You can't use the second person if they're in radio communication and your controls are still within range. We'll use visual observers.
Yeah, visual observer is another way that you can go line of sight. However, we found operationally, that's a complex workflow that requires more people, radio contact, you have to call them on the phone, and usually when you're doing that, why not just do the flight and then drive to where the visual observer is and has a second flight? And that's where that operational thing comes from, right? Just because you can do that, we found it's a complex workflow. It's absolutely doable. You can have a team of 10 people that are all stationed at perfect equal intervals along the line, and you have radio and cell phone communication, and you can hand off visual ID of the drone from one person to the next to the next. And that's a ridiculously complex and time-consuming and costly way to survey 10 miles when you can have 1 or 2 guys in one truck, rather than 10 guys and a whole bunch of complex radio procedures. So is it possible? Absolutely, but it goes back to what I was saying. Just because it's possible doesn't mean it's a good idea.
We've done some projects on areas where it's like national parklands or national wildlife areas where you're they can't restrict your access to fly above them, but you can't launch or recover.
Yeah, there are always going to be some very unique edge case scenarios for a lot of these things. I could talk for hours on just a lot of those edge cases, because many of them are very interesting. And if you need that, we have a whole flight operations and mission planning team that we're happy to talk to and help you guys figure out any of those unusual cases. We have done a lot of very unusual cases, ranging from someone needed to do a hydrological survey of a property with a non-compliant owner that wouldn't let the wouldn't let the surveyor on at all. They were suing someone and they wanted to be able to do a rough topo to show where the water was going to go in a court case to basically say that this crazy person was being crazy. They're like, so I have no access to the site, I can't set control, and I need to be able to get as good data as I can out of it. Things like that are very unusual, and there are ways around them. There are different best practices and procedures and things like that. So we were able to help them out and be able to get a good survey of the flight. But yeah, there are lots of interesting edge case scenarios here. Overlap in mission planning, when you are doing those multiple flight segments, when you are picking the drone up and moving, we like to see a little bit of overlap between the two flights there. This one's probably a bit too much, but you really want the photos to overlap, and ideally having a control point in those overlap zones really helps with accuracy, particularly when you are doing very long chains where you're daisy chaining 5, 10, or 15 different flights in these long corridors. Having control points in those overlap zones definitely help. It is recommended for RTK, PPK projects is what I say, and absolutely required if you are not using RTK on the drone. As far as distance from the operator, like I said, it's perfectly okay to move takeoff locations, try and stay within visual line of sight, and good rule of thumb is wherever possible, try and take off from the higher points on a job site. If you do have a lot of, hilly terrain and that sort of thing, if you can take off towards the higher end, that typically helps with reliability, just being able to see the drone, good stuff like that. Some more GCP placement stuff. Like I said, with large projects and other things, an ounce of prevention is worth a pound of cure. Mission planning matters a lot more the bigger the job site is, making sure your flight altitude and overlap is correct. Don't collect too much data, and even with all of this, parallel block processing is often required. That's on the data processing side of things. For anyone that is using photogrammetry, you can't just throw 10,000 photos at a Pix4D license, even with the most powerful computer in the world, and expect it to work in any reasonable amount of time. So breaking up, you fly with all this, then breaking up the photogrammetry processing into multiple individual blocks is typically the best workflow for processing many of these very, very large projects. Large, I say, we usually like to break things up at around 2,000 to 3,000 photos in each individual block is kind of the higher end before we wind up breaking it up into multiple individual segments and processing those individually. Field data collection, this will go pretty easy because, like I said, the drone flies itself. You do want to make sure that you collect all the data that the drone can't from the ground. That includes things like boundaries, building corners. Building corners are an interesting one because you can get building corner data from a drone, but typically it is not of the accuracy that surveyors require for building corners. The building corners themselves are obviously going to be obstructed by eaves very often, or by the building itself on the outside, so you only have kind of one view at it. And there's often shrubs, vegetation, things like that, so we usually recommend getting building corners on the ground. Monuments on the ground, things that are ADA compliant typically require that, a couple hundredths of a foot accuracy for something like that. Any obscured areas or anything else that needs to be very, very high accuracy is something that you should collect on the ground. When you are out in the field, marking ground control point makes a big difference actually as far as ease of use in the office. Bad ground control points are things that don't have an obvious center point. This is just a plain white tile that we don't particularly love. It adds a little bit of just noise finding the exact center. Corner of concrete is something that we actually really don't like for control. It's not easy to pick out from a photogrammetry standpoint. And also, especially if the person doing the photogrammetry is different from the person that was in the field, how do you know if it's that corner or you're marking that corner or a different corner? It becomes really, really messy to actually getting it accurate. Not insurmountable, but just not a great workflow. It adds a lot of time and confusion and reprocessing. Chevrons, I should point out, I've said this before, I really don't like chevrons, not because they don't let you see a good tip, but because some surveyors mark the front tip, some surveyors mark the inside corner. We've even seen a few people mark the absolute center between the inside and outside corner and that sort of thing. And the only consistent application of chevrons is that every surveyor thinks that the way they do it is the way that every other surveyor ought to be doing it. But that's not, as a photogrammetrist, that's not the way that we've seen it. Including this is my favorite ground control point. Honestly, you make me smile like that, keep doing it. That was wonderful. You can even see the nail right there, center mass. That's your best ground control. But no, those ones are our favorite. Our favorite is just standard, basic checkerboard targets. Black and white is totally fine, even though black and white was invented for an era when photogrammetry was in black and white itself. So we prefer bright, crazy colors. This projector doesn't do justice to how obnoxiously bright that pink color is on the ones that we like to use. As far as field operations go, that's pretty easy. You just check your site for restrictions, your airspace, things like that, checking your weather forecast, creating and saving your flight plans, pack all of your equipment up, set up your GPS base station, take a quick look over the drone, survey your ground data, load mission, and click go. And as you'll notice, for all of this hour and a half talk that I'm giving, this is the only advice I'm going to give you on how to fly a drone in the field. Click go. It's that easy. You really don't need more than click go. And if something goes wrong, click the come home button. That's it. That's really just about all there is to it. In fact, you're way more likely to get yourself in trouble by trying to do all kinds of fancy stuff rather than just keeping it simple, clicking go, and if something goes wrong, click come home. Yeah.
Setting up your base station, do you normally put that up on one of your ground control points, or is that separate, or?
Sorry, let me turn that off. No, we usually don't. Our preferred workflow, especially with the DRTK2, because as mentioned, it's kind of hardware is not super great. Also, its support for arbitrary or local coordinate systems is terrible. It doesn't even support NAT83. You have to use exclusively WGS84, which I hate. So no, what we actually typically do with a lot of our processing workflows is set it up over an arbitrary point, and then we actually get an Opus solution on wherever that GPS point was, so that we can correct multiple flights relative to one another or across different days or that sort of thing. So we get to do an Opus solution on wherever the GCP is, or wherever the base station is, correct all the photos relative to that, and then merge different days, different flight locations together with one. So you can, and this is one where depending on the different hardware, especially if you're in a non-DJI environment, some of those may require you to set your base station up over a known point. Part of the added workflow complexity with some of those other ones, like I know a lot of other non-DJI LiDAR systems, you really must set your base station over a known measured point in advance in order to get good data. All sorts of complexity. So generally speaking, no, you don't need to set your base station on a known point.
So in theory, you're just setting up middle of the site, ideally, and wherever. And
Yep. Middle of the site ideally, and it's the real world, so not everything's ideal, so set it up where you have access and fly it and go. But totally arbitrary point is fine. You can handle everything else in post.
You say it's more important to set up in the middle of the site or on the high ground?
High ground.
Okay.
Yep. That's not a super strong one, right? Like a lot of it's just, usually it'll be determined by site access more than anything, right? If the middle of the ground has a road going through it and the high ground would require you to hike for 20 minutes, yeah, go in the middle, that's fine. Site access, a lot of these things aren't super hard and fast rules. They are guidelines when it is practical.
Is that the high ground that's preferable because accuracy from photo height?
And overlap accuracy as well. So one of the things, if you fly, so let's make an extreme hypothetical. Let's say you fly at 100 feet and there's an 80-foot hill in there. The drone's going to be only 20 feet above the ground at that point, and that means your overlap's going to be really low. When it takes a picture, it's going to be so close to the ground that you don't actually have enough effective overlap on that high point. That's the extreme example, and that does work in the real world too. If you fly at 200 feet, and then the ground goes up by 50 feet, you're only 150 feet above ground, it slightly lowers the effective overlap. So that's what a more real world circumstance will look like. So generally speaking, the higher ground gives you a little bit better reliability and accuracy.
So on that note, when you go out to a job site and you're doing your mission plan, do you, when you're deciding your height, I mean, if your site has hills like that, do you do your height based on average?
Yes.
Average height of the ground or highest point or?
So I would say, number one, don't overthink it. If you have 50 feet changes or 100 foot changes, take off from the higher point and go about 200 feet. A lot of this, there is wiggle room in all of these things. That's part of why we do 75-75 overlap, is that if the ground goes up, the effective overlap lowers, you're not in a lot of trouble. If you're operating at the bare minimum by saying, 55 or 60% overlap, then a tiny increase of elevation will cause some problems. But this is all of this system is baked to be flexible a little bit. You're not operating on the absolute limits anywhere, because then you would have to worry about all of that little ticky-tack stuff. And that all takes more planning, that all takes mind share, that all takes time, and that's a pain. So that's part of why we have all of these best practices, because they're the ones that actually make it harder to trip up and to cross one of those almost invisible things. So don't overthink it is the answer. The difference between a 200-foot flight or a 225-foot flight is negligible. All right, so what happened here? Keep this going. All right, so we are running out of time, so I'm going to go through the office workflow stuff really quickly. By the way, if you are interested, I'm going to go deep into a LiDAR office workflow in my 3:30 talk later today, if you are interested. So the office workflow, just high level, is it starts with photogrammetry. So photogrammetry is where you stitch the images together using a software like Pix4D into a point cloud, orthophoto, and digital surface model. The LiDAR processing is when you take the drone's raw LiDAR data, you turn it into a LAS point cloud, classify it into your ground, vegetation, building, etc., creating your elevation model and converting the data into your useful formats. Then the next step, once you are through there, is what we call the line work drafting phase, which is going to be reducing those rich 3D models into a CAD-friendly surface. Because for anyone that's dealt with drone data, you know the rich 3D models are very, very, very large. You can't put a 5 gigabyte orthophoto into Civil 3D, it will explode. Nor can you put in a 200 million point cloud into Civil 3D, it will not like it. So reducing it down to CAD compatibility by actually extracting topo points, as well as your other features, whether those manholes, utilities, curb lines, that sort of thing. And then finishing it all in CAD. That means merging in your field data, creating a surface that is a merge from all of the data you have, adding in your symbol, site culture, annotation, sealing it, so that your finished survey deliverable is the same. So, to go into a little bit more detail of what a good office workflow looks like, and again, having this procedure, these steps codified, are really important to making it that repeatable workflow that we talk about. Starting with photos, ground control, RTK and BPK, running it through the photogrammetry and LiDAR processing step. That will get you the intermediate deliverables, what we call the rich model deliverables, your point clouds, digital surface model, and orthophoto. You run through your line work drafters that actually extract that into 3D points, polylines, typically in like a DXF CAD format, much more lightweight at this point. Run it through CAD finishing to get your surface contour, site culture, all of that, and that is what gets you your final deliverable. This is what a good office workflow ought to look like. And since we are running out of time, let me see here. I unfortunately don't have time to go through all of the photogrammetry and other stuff, but so I will just kind of wrap this up by saying a lot of these summaries that I have said before. The goal is to save time and money. All of this is trying to make things simpler. It is always possible to make things harder on yourself. My goal is to go the other way, make it cheaper, simpler, more reliable, easy to use. And if your drone program isn't saving time and money, then it's not working and something ought to be changing, because this technology is well mature enough at a point where it is far beyond that research project phase. You should be saving time and money. You should pick the right tool for the job, whether that is a drone, total station, or GPS. Use a complete workflow, and also shameless plug as well, if you are having troubles at all, we do drone data processing for surveyors. You should check us out and let us know. We would love to process some of your drone data, and in fact, we would be happy to give anyone who's new a free project just to show you what we can do with all of your data as well. So thank you for your time and attention. If you would like a copy of these slides or a video recording of this presentation to share, please reach out to me at aerotas.com/LSAW22, or my email is logan@aerotas.com. Thank you for your time and attention. I appreciate it.